These next couple problem types will relate to something called systems of linear equations with two variables. Now, before we talk about that, let's talk about what that whole big title means. To start with, linear equations. Obviously, these are equations that would give you a line. We've talked about a bunch of those. A straight line, as opposed to something like the graph of x squared, or the graph of x cubed. This one is linear. These two are nonlinear. Basically, anything that has a curve would be nonlinear. Next point is two variables. We're using two variables because we have both x and y. This is as opposed to something like if you had x plus 5 equals 2. There's only one variable in this, or if you had x plus y plus z equals 0. Well, that has three variables, but in ours we're only using two variables. Now this word systems. Systems basically means that you have equations that go together. If you take them apart, they do not mean the same thing. That's what this brace here means. It means that they are a system and that they go together. So our first problem type that we're going to solve is determine whether a given ordered pair is a solution of the system. Now this is a relatively simple type problem. We have two equations. We have our 9x plus 7y equals 8, and we have 8x minus 9y equals negative 69. Now we also have a ordered pair right here, which has an x coordinate and a y coordinate. Now all we have to do is essentially plug those numbers in. So wherever we see x and y, we want to plug those numbers in. We have y equals 5 and x equals negative 3. So that we have, if we continue to solve that out, we have negative 27 plus 35 equals 8. And then if you solve that, you end up with 8 equals 8. Now this is true, so we're off to a good start so far. We want to determine whether or not, if we plug in the pair with each of these equations, it will be true. So let's go ahead and do the other one. Again, we're using the same numbers for both because the ordered pair goes with both equations that are in the system. And again, we solve it to find that negative 69 does equal negative 69. We know this is true. So, since both of those are true, we say that negative 3 comma negative 5 is a solution. And that is the answer to that example. So we were asked to figure out whether it is a solution to the system. We plugged the numbers in, and we got true statements both times. Therefore, it is a solution. Now let's look at this second one. We have our equation x plus 2y equals 2, and x minus 2y equals 6. And again, we have our given x and our given y coordinate, if our ordered pair. And again, we just want to plug them in and see if they hold, is what we say. See if it holds true. We had -4 this time, so -4 for both of those. All right, this is a new example, forget the last one. And our y is 3. And then if we solve that out, we say that -4 plus 6 equals 2. -4 minus 6 equals 6. So now here we have 2 equals 2. That one's true, that one's good. But over here, we have -10 equals 6. And we know that is not true. Therefore, because one is true and one is not true, it doesn't matter if one is true, but because this one is not true, we say that -4, 3 is not a solution. And that is the answer to that problem. Again, it doesn't matter if one's true. If anything in there is not true, it is not a solution. That would also apply if both of them were not true, it's not a solution. Only if both of them are true, like in example 1, where 8 equals 8, we know that's true, and -69 equals -69, that's also true. Therefore, it is a solution.